Newton's first law states that an object in motion will stay in motion, and an object at rest will stay at rest, unless they are acted on by an outside force.
This can be demonstrated by something as simple as a ball. This ball right here will stay at rest as long as nothing, such as an outside force, touches it or moves it. But if an outside force, such as your hand, hits it and adds force to it, it will go into motion. Well, once it goes into motion, nothing will stop it unless another outside force. In the case of the ball will be stopped by friction from the ground, as demonstrated. It's staying in motion until the friction stops it right there, and it will no longer be in motion anymore because it's going to stay at rest via Newton's first law.
Newton's second law states that force equals mass multiplied by acceleration. Here we have two objects of different masses. One, a ball, and two, a dumbbell with 20 pounds on it. I can apply the same amount of force to these two different objects. Just because this ball right here has less mass than this dumbbell right here does not mean that they will have different forces applied to them, because force equals mass times acceleration. So, say that this ball right here has an acceleration of 2 meters per second when force is applied to it, and that it weighs 1 kilogram instead of however much it actually weighs. We could say that then this dumbbell right here, instead of the 20 pounds that it actually weighs, that we can see, it actually weighs 20 kilograms. In this case, when a force is applied to it, we could say that it accelerated at 0.1 meters per second. This would mean that 2 times 1 and 20 times 0.1 would both equal 2 newtons of force. This means that even though they had different masses, but different accelerations, they still had the same force in the end. That is because of Newton's second law stating force equals mass times acceleration. Newton's third law says that for every action there is an equal and/but opposite reaction. This works perfectly with things such as this ball right here on the floor, because there is gravity pushing down towards the floor, and with that action there's an equal but opposite reaction from the floor pushing up on the ball, meaning the ball will stay right there where it is because they're both equal. So it's pressing down and going back up at the same rate, meaning it will stay right there and rest. This is better shown in a diagram such as this, showing that force of gravity is moving downwards towards the ball, as on the floor right here, and is being pushed. Force is being pushed back up towards the ball by the opposite but equal force by the floor. In recap, we see that Newton's first law says that an object in motion will stay in motion, and an object at rest will stay at rest unless acted on by an outside force, which was shown by the ball staying at rest when nothing was moving it or acting force onto it, until my hand hit it, where it stayed in motion until friction stopped it, which acted as the outside force. Then there was Newton's second law, which says force equals mass multiplied by acceleration, or F equals ma. This was demonstrated by a dumbbell that weighed 20 pounds, or as we put it, 20 kilograms, and a ball that we said weighed 1 kilogram. The ball went 2 meters per second, while the dumbbell went 0.1 meters per second. This made them both equal up to 2 newtons of force. And Newton's third law says that for every action there is an equal and opposite reaction. This was demonstrated by the ball on the ground with gravity pushing down while the force of the floor pushing up.